All right, this is quiz number 1 for Physics 101 3T. Which of these is the current standard for the kilogram? The current standard is the mass of a particular cylinder. The standard is shifting away towards this the mass of a certain number of silicon atoms. But right now, the mass of a particular cylinder. What must the units of Q be? So this equation is dimensionally correct. Now let's just X is in meters, T is in seconds, V is in meters per second. And this is going to equal Q over meters per second squared. Let's rewrite this a little bit. First of all, our meters will cancel out, and we're left with seconds squared on this side. And then I can have Q seconds squared over meters. So that means that Q must be in units of meters. That's B. Consider this triangle. What is the side X? This is a special triangle. It's a 3, 4, 5 triangle, so I can say right off it's 3. Or you can say x squared plus 4 squared equals 5 squared. That's x squared equals 25 minus 16. If you're not aware of that special triangle. All right. Consider the triangle. What is the angle theta? So now what is this angle theta? Well, now I know 3, 4, and 5. I can do any one of these. I can say the tan of theta, any one of the trig functions, equals opposite over adjacent. That's 4 over 3. And so theta is the inverse tan of 4 over 3. Which is 53 degrees. So the answer for this one should be 53 degrees. All right, I'll have to come back. I must have a mistake here. I have the correct answer. The answer is 53 degrees. I'll put it, the answer will actually be listed as 50 degrees on the quiz, so I'll have to correct that. But the answer is 50 degrees. All right. Which of these is, or excuse me, in square millimeters, estimate the area of this box. If you had a ruler, you would see that this box is 2 centimeters by 2 centimeters. All right, so that's in millimeters, that's 20 millimeters by 20 millimeters, which is 20 times 20 is 400 square millimeters. So that's A. Which of these is the answer considering appropriate use of sig figs? All right, so if I add these two up, I keep the lowest number as sig figs, so that's going to be 7.0. Down here, I keep the lowest number as, oh, excuse me, up top, I keep the lowest number of decimal places. And down bottom, I keep the lowest number of sig figs. So this is the lowest decimal places. And then down here, I keep the lowest number of sig figs. All right, so 0.50 times 14, those both have 2 sig figs, so that's going to be 7.0. And so 7.0 divided by 7.0 should be C, so number 6 is C. When throwing a ball straight up, which the following is true about its velocity v and its acceleration at the highest point in the path. When I throw something up, it goes up, it comes back down again. Up here, the velocity is equal to 0, so I know that that can't be true, nor that one. But the acceleration is not 0. The acceleration is always minus 9.8. Consider this position versus time graph. What is the average velocity from 20 to 40 seconds? So I'm looking from here to here. My positions are 50 and 10, and going from 20 to 40 seconds. So I say 50 minus 10 meters over 40 minus 20 seconds. That's 40 over 20, which is 2 meters per second. That is C. Consider the above graph. Where is the speed of the object greatest? Let's just mark these times. 45, 55, at 45, 55, 38, and 10 seconds. And I can find the tangent lines for each of these. All right, this one has the steepest tangent line. Even though it is negative, it's still a steeper tangent line. And so that was, what, 45 seconds. So A is number 9. Man jumps from a space capsule towards Earth. What is his speed after 10 seconds? All right, well, V is equal to V0 plus AT. So it's just 0 plus minus 9.8 times 10, which is 100 meters per second. Keeping proper sig figs, how far does he travel? X is equal to 1/2 AT squared. That's because V0 is equal to 0, so I just didn't write that term. So that gives me 1/2 of minus 9.8 times T, which is 10 seconds squared. That's 5 times 100, 500 meters, which is A for number 11. Number 12, consider this graph. What is the sign of the acceleration? Well, notice that I have negative velocity that is decreasing in magnitude. So negative velocity, and it's slowing down. So that means that the acceleration has to be opposite the velocity, so it's positive acceleration. This graph shows the velocity versus time graph for 3 separate cars, A, B, and C. Which of these statements is false? All right, car A initially has a larger acceleration than car B. The acceleration is given by the slope. You see the slope there is bigger than it is there, so that one is a true statement. Cars A, B, and C all travel the same distance. That is not true. Car C travels the area under that plot. Car B travels the area under that plot, and then car A travels the area under that plot. So car A travels a much further distance. So that is the correct answer because it's an untrue statement. Let's finish up. I'll just look at the rest of these. Car C finishes with a larger acceleration than car A, but the acceleration is there. Car C has a much larger slope, so that is a true statement. And cars A, B, and C all reach the same velocity. They do. They all reach this velocity, which is their final velocity for all of them. So that's number 13. That's the end. There are the answers. Remembering, of course, that there was that mistake on problem number 4. The answer should be 50 degrees, and that will be one of the options on the test, 50 degrees.